All right, welcome everybody. What we're going to look at today is electron transfer, and we're going to continue talking about ionic nomenclature. So we're going to talk about how to name ionic compounds. We'll talk more or review more about what an ionic compound is and so forth. But what I'd like you to do now is I'd like you to take a minute, pause the video, and I want you to answer these review questions. So starting with review questions 1, 2, and 3, including labeling the periodic table. And then I want you to see if you can answer questions 1, 2, 3, and 4 regarding ionic bonds. Okay, so when you get a chance, pause the video. I want you to answer questions 1, 2, and 3 on your own as kind of like a warm-up. And then, in addition to that, answer questions regarding ionic bonds here down below. Okay, and then you can press play to kind of check your answers to see if they're correct or not. So go ahead and pause the video and get started. Okay, so to kind of review and recap what we talked about, if an atom loses an electron, if an atom loses an electron, it becomes a positive ion. And we know that positive ions are cations. If an atom gains an electron, so this is if an atom loses an electron, if an atom gains an electron, then it becomes the opposite. So it becomes a negative ion, also referred to as an anion. So metals typically lose electrons. Metals are typically cations, and nonmetals are going to be the atoms responsible for gaining electrons, which are known as anions. So the ion symbol for the following atom. So if sodium loses one electron, so I need to start with a symbol for sodium, which is Na. And if it loses one electron, then now it's going to have more protons than electrons. So it becomes positively charged. So it's going to be a positive or a +1. Calcium is Ca. And if calcium loses 2, then now it's going to have 2 more protons than electrons. And it'll have a +2 charge. Okay, looking at nitrogen. So the symbol for nitrogen is an N, and nitrogen, it says it's gaining 3 electrons. So now it's going to have 3 more electrons than it does protons, and that'll give it a -3 charge. And chlorine, the symbol Cl, is going to gain 1 electron, so it's going to have 1 more electron than proton, so that'll give it a -1 charge. So down below, you're asked to label the charges and the valence electrons for the periodic table. So let's take a look at it. So group 1 elements all have a 1 valence electron, so they will have a +1 charge when they lose that electron. So 1 valence electron. We'll start with the valence electrons too. Group 2 has 2 valence electrons. Group 13 has 3 valence electrons. We're going to skip over the transition metals. Group 14 has 4 valence electrons. Group 15 has 5, and so forth. And group 18 has 8 valence electrons, with the exception of helium. It only has 2. So now let's take a look at the charges. So group 1 elements have 1 valence electron, so they are going to give up 1 electron and they'll become positively charged. Group 2, they're going to give up 2 electrons. It's easier to give up 2 than to find 6 more. So when they do that, they'll have a +2 charge. We'll skip over the transition metals again. Group 13 has 3 valence electrons. They're going to give away 3 rather than find 5. They'll have a +3 charge. Group 14 is unique because they can either gain or accept. It's just as easy to do either, positive or minus 4. And that's our threshold. Once we cross our threshold, now we are looking to gain electrons. So group 15 has 5. It only wants 3 more. So when it gains 3, it's going to take a negative 3 charge. Group 16 has 6 valence electrons. It needs 2 more. So when it takes in those 2, it becomes minus 2. Group 17 has 7 valence electrons. It only needs 1 more. So when it gains that 1, it'll have a minus 1 charge. And group 18 has 0 charge. So the noble gases, they are stable. All right, so looking at ionic bonds. Let's recap some stuff on ionic bonds. So an ionic bond, if you remember, occurs between a metal and a nonmetal. So an element from the left side of the periodic table bonds with an element from the right side of the metalloids, metal and a nonmetal. And what they do is that between those two nonmetals, or a metal and a nonmetal, the electrons become transferred. So what you can see here is I've got a sodium atom, and it's transferring. It's showing this electron is being transferred to the chlorine atom. So I know that sodium is my metal, chlorine is my nonmetal, and this electron is being transferred. Okay, so now what you end up with is sodium has 1 less electron, so it becomes positively charged, and chlorine gained an electron, so now it becomes negatively charged. That's why we call it an anion for chlorine and a cation for sodium. So the process of the bond, the metal transfers the valence electrons to the nonmetal. Okay, we're only talking about the valence electrons in this case. It transfers the valence electrons to the nonmetal. It's never the nonmetal to the metal. It's always the metal transferring the electrons to the nonmetal. Okay, when that happens, the metal becomes a positive cation, and the nonmetal becomes a negative anion. So remember, metals are positive, nonmetals are negative. So the metal and the nonmetals bond. So in other words, they stick together. There's an electrostatic attraction between those two elements, between those two atoms. Okay, so remember that opposites attract. So opposite charges attract. So if I've got a positive metal and a negative nonmetal, those opposite charges will attract each other. And so after that transfer, both atoms are happy, they are stable, because now they have their octet. So now they are stable, just like the noble gases, and now they have a noble gas configuration. All right, moving on. So now we're going to look at how the electrons transfer in an ionic bond. So I got a few steps here. So step 1 says give each atom their valence electrons. Okay, so potassium is in group 1, and group 1 elements have 1 valence electron. Okay, so I'm going to give it 1 dot. That's not a very good dot. Here we go. Fluorine has 7 valence electrons, so it's going to have 7 dots. Okay. So step 2 says make sure the metal loses all its electrons, and make sure the nonmetal gets an octet. So if I redraw them, there's potassium, and then Fluorine has 7. Okay, so I'm drawing them for illustration purposes. Normally, I would draw them in a counterclockwise direction, and the unpaired electron would end up on the other side. But here, just for bonding purposes, I'm going to show you that potassium with one valence electron will share with fluorine. So potassium is my metal, so it's going to lose electrons. So this one electron here is going to transfer to fluorine, and it's going to fill in a space where there's not already an electron that's paired up. So you look, these electrons here are paired up. These electrons here are paired up. These electrons here are paired up. The only electron that's not paired up is this one. So this electron is going to transfer and fill in that empty space. Okay, so potassium loses 1 electron, fluorine gains 1 electron. Okay, so now I need to write the ion symbols. So potassium lost 1 electron, so it'll become +1. Fluorine gained 1 electron, so it is going to become -1. Okay, so remember the charges have to balance each other out. So if I've got a +1 and I add a -1 to that, then I get 0 charge. Okay, step 4, write the chemical formula by counting the number of atoms used to cancel out, both as subscripts. All right. So I'm looking at, here's my 1, here's my 1. These charges are going to be written as subscripts now. Okay, so I'll end up writing it like this. I'll write the metal, which is potassium, the nonmetal, which is fluorine, and then their charges, which were subscripts, will be 1 and 1. Now, as far as naming goes, I keep the metal's full name. So the metal is potassium. And the nonmetal is fluorine. And I'll write that down here below. You don't have to write it. But FLU, yeah, I think that's spelled right. So what happens is that the ending, INE, gets replaced with IDE. So instead of fluorine, I get fluoride. Okay. So now let's look at showing some more examples using the dot structures and electron transfer. All right, so what I'm going to do is I'm going to draw the dot structure on each atom first. So I've got calcium and I've got oxygen. So I'm going to draw my symbol, my dot structure for calcium, which is Ca, and calcium is in group 2, so it only has 2 valence electrons. And then I'm going to draw oxygen, okay, which is O. And oxygen is in group 16, therefore it has 6 valence electrons. So 1, 2, 3, 4, 5, and 6. All right. So what ends up happening is if you look, oxygen has a pair of electrons here, a pair of electrons here, but here this is unpaired, meaning there's an open space, and here there's an open space as well. So conveniently, calcium has 2 electrons, one to fill this empty space, one to fill this empty space. Okay, so what's going to happen is this electron here will fill this empty space, and this electron here will fill that empty space. So now calcium loses 2 electrons and oxygen gains 2 electrons. Okay, so now calcium becomes positive 2 and oxygen becomes minus 2. So the formula will be CaO. And I always write the full name of the metal first, which is calcium. And then instead of writing oxygen, I'll write that down here, I've got to add IDE to it. So what I end up doing is I get rid of the YGEN and add IDE, and it becomes oxide, calcium oxide. Okay. My next one is between calcium and chlorine. So I'm going to start with the symbol for calcium. So calcium is Ca. Chlorine is Cl. Okay, so calcium again is in group 2, so it's got 2 valence electrons. 1, 2. Chlorine is in group 17, it's got 7 valence electrons. So 1, 2, 3, 4, 5, 6, and for illustration purposes, I'll put 1 here. 7. Okay, so calcium is going to donate, it's going to give up, it's going to transfer its electron. Now, chlorine is going to accept it, but you notice that there's a pair here, a pair here, a pair here. The only available space for that electron to go is here. So if I take one of these electrons and transfer it, it fills that gap. But now, calcium isn't happy yet because it has 1 extra electron hanging out here. Okay? So in order to make calcium happy, it must take this electron and donate it to a second chlorine. So I'll draw a second chlorine atom, and then 7 valence electrons. 1, 2, 3, 4. Now again, for illustration purposes, I'm going to put 5 here, 6 here, and 7 here. So now the empty space is here. So what ends up happening is that this extra electron goes and fills that gap. So in order to make calcium happy, it needs 2 chlorine atoms. Okay? So I'd indicate that, excuse me. I'm going to write the symbol for calcium. And calcium gave up 2 electrons, so it has a positive 2 charge. Now, in order to make calcium happy, it needed 2 chlorines. And each chlorine gained an electron, so they became negative. So in my formula, I would indicate the number of chlorines with a subscript. So there's 1 calcium and 2 chlorines. So the subscript on chlorine will be a 2. So how do you name this? Well, remember the first full name of the metal, which is calcium. And instead of writing chlorine, remember we're going to add IDE to it. So I have to get rid of the INE and add IDE. So when I do that, I get calcium chloride. All right, my last one down here is potassium and oxygen. So potassium, we'll start with potassium, is the symbol K. And it's in group 1, so it only has 1 valence electron. Oxygen, we set up above, is in group 16, and it has 6 valence electrons. So 1, 2, 3, 4, 5, 6. So potassium needs to get rid of 1 to make it happy. So it's going to take this electron and transfer it to an open space for oxygen. So now potassium is happy. It got rid of its electron. But chlorine is not happy because it wants 8, but now it only has 2, 4, 5, 6, and the one it got from potassium making 7. So it needs to make this pair. It needs to fill up this pair. So in order to do that, it needs to go and find a second potassium atom. And that potassium atom is going to take its electron and make oxygen happy. So now, if you look at it, now I've got 2, 4, 6, and 8 valence electrons. So now oxygen is happy. So when I write that, each potassium gave up 1 electron. To an oxygen that gained 2, so it has a -2 charge. So I need to indicate that in my formula by writing the number of potassiums, which were 2, and the number of oxygens, which are 1. So how do I name this? Well, the first full name of the metal is potassium. And then instead of writing oxygen, I need to add IDE. So to do that, I have to get rid of the YGEN and add it to the ending. So potassium oxygen becomes potassium oxide. All right, and the last part of this is how to name these ionic compounds. So nomenclature is just a fancy word that means naming. So ionic nomenclature is referring to the naming of ionic compounds. So let's look at our first example. Okay, we always list the full name of the metal, and we add IDE to the nonmetal. So the first element here is lithium. It's my metal. So lithium. And then chlorine loses the INE and becomes chloride. Okay. In my second one, I've got aluminum and sulfur. So identify your metal. My metal is aluminum. My nonmetal is sulfur. So the full name of the metal, aluminum. And instead of sulfur, I need to add IDE. So I lose the ending UR and I add IDE, sulfide. And in my third one, potassium is a metal, nitrogen is my nonmetal. So write the full name of the metal, potassium. And nitrogen has to lose its ending. So the ending of OGEN and then add IDE, I get potassium nitride. Potassium nitride. All right, so what do the little bottom numbers in the ionic formula mean? Well, the little numbers at the bottom are referred to as subscripts. And the subscripts tell me how many atoms I have in a compound. Okay? If, like for example, this 2 right here. So this tells me that I have 2 chlorines. But by calcium, there's no number. So this is implying that there is 1. Okay, no number means it's implied that there's a 1. So the subscript on calcium, even though it's not written, is a 1. The subscript on chlorine is given to me, it's a 2. So in ionic compounds, the subscripts tell you how many of each ion is needed to balance those electrons, or to balance the charges. Okay? It's not an actual count of the total atoms, it's a ratio. Okay? So when I look over here at this example of the figure down at the bottom, I've got a calcium atom and a chlorine, 2 chlorine atoms. So of these, calcium is a metal, chlorine is a nonmetal. And what you see is that calcium's transferring 1 electron to chlorine here and a 2nd electron to chlorine here. So in order to make calcium happy, it needs to transfer 2 electrons, which means it needs 2 chlorine atoms. So this formula would be, it would have 1 calcium, 2 chlorines. So I would use subscripts to imply how many I have. So 1 calcium, 2 chlorines. Now this 1 is implied. So most commonly you'll see it written as CaCl2. The 1 is implied. We do not typically write it. Okay. So again, the subscripts in an ionic formula tell me the ratio. They represent a ratio of ions. How many ions are needed to make it neutral? Okay. So we looked up above in that figure. My formula is CaCl2 for calcium chloride. So that means I've got 1 calcium ion and 2 chlorine ions, or chloride ions. So the ratio is 1 to 2. For every 1 calcium ion, you have 2 chloride ions bonded with it.